Hello everyone, my name is Xifan Zhang from School of Foreign Languages, Tongji University. Welcome to see this video. My topic is an eye tracking study on Mandarin tone perception of children. My presentation is divided into 4 parts. There are introduction, methods, results, and discussion. Now let's move to the first part, introduction. As we all know, pitch plays a significant role in the perception of speech. In non-tonal languages, pitch conveys information from word stress and utterance accent to pragmatic stance and speaker emotion. However, in tonal languages, pitch is used to differentiate lexical meaning of words particularly. As you can see on the screen, there are the 4 tones in Mandarin, which are ma, 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 ma. There are the high level tone, the high rising tone, the low dipping tone, and the high falling tone. The same segmental information ma in Mandarin can represent the meaning of mother, hemp, horse, and scold with these 4 tones respectively. There are 2 phases in the cognitive process of tones, namely local processing and global integration. In local processing, speakers identify tones from acoustic cues, such as pitch primarily. Then, speakers combine acoustic features with linguistic meaning in global integration phase. In tonal languages, the boundary between low and high dimensions is not that clear-cut. It is found that individuals whose native language are tone languages perform better in both producing and perceiving musical pitch. Besides, native speakers of Mandarin have a preeminent categorical perception of high-dimensional speech signal compared with those of English. The research summarized above supports the notion that the fine-tuning caused by language acquisition is demonstrated in the processing of critical auditory dimensions in the speech signal, and it can be conveyed over into non-linguistic domains like cognitive perception. Therefore, in this study, we focus on the tone perception of Mandarin-speaking children and explore its characteristics. Recent works on Mandarin tone perception of children mainly concentrate on special populations, since it is conducive to their diagnosis and intervention. For example, it is shown that acoustic children have the advantage of local processing compared with typically developing children, while having defects in global integration. Previous studies analyzed Mandarin tone perception of children based on behavioral experiments, while in this study, we use SMI and eye tracker to explore the mechanism of Mandarin tone perception of children and expect to answer the following questions. First, is children's perception of pitch change more sensitive to speech sounds or non-speech sounds? Second, is tone perception of Mandarin-speaking children dependent on acoustic cues or integrated information in speech? Third, is the pitch perception of children influenced by semantic information in speech? With these questions, we designed an experiment. We recruited 11 children participated in the present study. All of them speak Mandarin Chinese as their native language and have no history of vision or hearing impairment. Some stimuli were monosyllable real words, pseudo words, and filtered words. The real words contain all 6 monophthongs in Mandarin, namely a, o, e, i, u, yu, and 1 diphthong, ao. As for pseudo words, vowels were as the same as the real words, while initials were changed to make them meaningless. Let's listen to the examples. real words,
毛
pseudo words,
毛
filtered words. Filtered words were created by Pratt using real words as prototype. Page contour of real words was extracted and then resynthesized with sine waves. Therefore, the spectral information was eliminated from the acoustic signals, leaving only the pitch information. And also in different tasks, we use different image stimuli. In the pitch highlighted identification task, the image stimulus in which the driving path of the car simulated pitch changes showed four pitch contours of Mandarin tones without any semantic information. However, in the semantic highlighted identification task, the image stimulus showed the lexical meaning of the words instead of the pitch contour. The pitch highlighted identification task investigated children's perceptual ability of identifying pitch directions. The semantic highlighted identification task tested children's perceptual ability of extracting linguistic meanings by integrating pitch and semantic information in acoustic signals. According to different tasks, the sound stimuli were also different. In the pitch highlighted identification task, 3 blocks were designed with the same image stimulus and the sound stimuli of real words, pseudo words, and filtered words respectively. And they were presented in random order. Each block randomly played sound stimuli twice for a total of 2 rounds. And each trial lasted for 6,000 milliseconds. Participants were required to stare at the corresponding picture, matching the pitch contour of the sound stimulus. However, in the semantic highlighted identification task, the sound stimuli were only real words. And the image stimulus, for example, 竹, can represent the meaning of pig, bamboo, boil, and pillar with different tones. Participants were required to stare at the corresponding picture, matching the lexical meaning of the sound stimulus. The two tasks were counterbalanced among subjects. The statistical software of SMI, BGAZE, was applied to divide the image stimulus into 4 areas of interest and collect detailed AOI data. The relative staring duration (RSD) of the target AOI was calculated statistically. Therefore, the higher the RSD, the more accurate the children's perception of the pitch direction or meaning of each tone. Now, let's see the results. As can be seen, children performed much better when sound stimuli were pseudo words. In order to further analyze the influence of sound types and tone types on tone perception statistically, a linear mixed model using the Elmer test package in R was conducted, where the independent variables were sound stimuli and tone types, and the random factor was participants. Results showed that there was no significant effect of tone types on the tone perception of children, but a main effect of types of sound stimuli. No significant two-way interaction was found between sound stimuli and tone types. In order to explore the within-group effect in sound stimuli, a post-hoc multiple comparison test was conducted using the multi-count package in R. The results, as represented in the table, revealed that filtered words motivated a significantly smaller RSD than both real words and pseudo words in the pitch highlighted task, whereas there was no significant difference between real words and pseudo words. Besides, the results showed that real words in the semantic highlighted task did not motivate a greater RSD when compared to other sound stimuli. Now, let's move to the last part, discussion. Our results indicated that Mandarin-speaking children showed superior performance on the pitch perception of speech instead of non-speech, but comparable performance on real words and pseudo-words in both the pitch highlighted task and the semantic highlighted task. And also in our study, when comparing with filtered words, RSD of pseudo-words was relatively higher than that of real words. In the case that real words and pseudo-words both contain the information of the frequency domain, real words also carry the semantic information. So the result indicated that the semantic information of words may interfere with the tone perception of Mandarin speaking children. The previous result seemed to turn out that the semantic information of words would hinder children's perception of tones. However, real words and pseudo words in the page highlighted task showed no significant differences, meaning that the Mandarin tone perception of children was in the same level in different stimuli of speech sounds. In Mandarin tone perception, children perceive tone information through the acoustic cues perception and the semantic information integration of speech sounds. When the speech stimulus is presented as a real word, both two channels would work simultaneously, and when the sound stimulus is presented as a pseudo word, the channel of semantic information would not be triggered. So the experimental results show that basically the tone perception of Mandarin speaking children in speech sounds could not necessarily rely on the channel of semantic information of words, but on that of acoustic cues. In other words, children still tend to perceive Mandarin tones based on acoustic features in high-dimensional cognitive processing. However, it does not mean that children cannot perceive Mandarin tones through linguistic meaning or integrated information in high-dimensional cognitive processing. The present study conducted a semantic highlighted task to compare with the pitch highlighted one. Under the circumstance that the sound stimuli were all real words, and the image stimuli presented on the screen were divided into two categories, the pitch diagrams and the semantic diagrams. So the result indicated that children could perceive Mandarin tones through both pitch and the semantic information in high-dimensional cognitive processing, since there was no difference between real words in semantic and pitch highlighted task. Furthermore, it showed that children had the ability to distinguish between acoustic features and the linguistic meanings in global integration. And the results of the present study showed that children, like adults, also had the ability to perceive Mandarin tones through acoustic or semantic cues alone. That's all of my research, and thank you for your attention. If you have any questions, welcome to contact me.